Good day, everybody. This is Dr. Nandi. Today we are going to talk about hypothesis test difference in two proportions. So I'll share my computer screen with you. In a sample of 80 Americans, 55% wished that they were rich. In a sample of 90 Europeans, 45% wished that they were rich. At alpha equal to 0.01, is there a difference in proportions? Find the 99% confidence interval for the difference of the two proportions. Okay. Solution. No, let me change the color of the ink. So solution. Let 1 equal to Americans and 2 is equal to Europeans. We have been given N1 is equal to 80 and P1 hat sample proportion 1 is equal to 0.55. So if you remember, P1 hat is sample 1 proportion of success, which is number of successes divided by sample size. Now, number of successes we call by X1 and sample size we call N1. So P1 hat has been given as 0.55 is equal to X1 over sample size N1 is 80. Now we will multiply by 80 on both sides to solve for X1. Number of successes is X1 divided by 80 multiplied by 80. This 80 cancels, and X1 is number of successes in sample 1 is equal to 80 times 0.55 is 44. So number of failures in sample 2, in sample 1 I mean, is 55 total sample size minus, sorry, I'm totally wrong. This sample size is sample size minus number of successes. Minus number of successes. Number of successes. Which is 80. Oops. So excuse me, I have to move this. If I may move this. So number of failures in sample 1 is 80 minus 44. So in your calculator, you can do 80 minus 44 is 36. So both number of successes and number of failures are greater than 10. Greater than 10. We can use normal distribution. Solve this problem. Okay, let me create some more space. Similarly, N2 for number of Europeans is 90. Okay, N2, so N2 let me make sure I know. N2 is 90 and P2 hat is 45%. Okay. So also given N2 number of Europeans is equal to 90 and P2 hat is equal to 0.45. So just like before, P2 hat is equal to 0.45 is X2 over N2, or 0.45 is equal to X2 over 90. Now we will multiply by 90 on both sides. So X2 will work out to 90 multiplied by 0.45. So 90 multiplied by 0.45 is 40.5, which we will round to 41. Okay. So this is the number of successes in sample 2. Successes in sample 2. So number of failures in sample 2 is equal to total sample size is 90 minus 41 is equal to 49. And so if I create some space, in sample 2, both number of successes and number of failures are greater than 10. Okay. So we can use normal distribution to solve this problem. This problem. That is we will assume that the sample proportion sample okay I have to use that the difference in the sample proportion in sample proportions P1 hat minus P2 hat follows a normal distribution. Okay, let's look at the problem again. So at alpha equal to 0.01, is there a difference in the proportions? That is the question. So some of this, okay, we'll need some of this information. Specifically, we need information for x1, n1, x2, n2. So let me write down the null hypothesis and the alternative. So first I will write the, I'll move this a little bit. So alternate. So first I write the null hypothesis is P1 minus P2 population proportion difference is 0. Alternate is P1 minus P2 not equal to 0. This is difference in two population proportions. Notice there are no hats on top of them. So these are population proportions. Is P1 minus P2. Okay. So we'll use TI-84. TI-84. Press the stat button, then test button. Then highlight test on the top row and scroll down to 2 prop Z test. So stat, test, and scroll down to 2 prop Z test and hit enter. Okay. And then enter. So if I create some space, so it is asking for x1, then it's asking for n1, then x2, then n2, then the alternate hypothesis P1 and our alternate is not equal to P2. So we'll bring it the cursor on not equal to P2 and hit enter so that it's flashing on not entering and not equal to P2 is the alternate. Now we have to plug in the values of x1 and n1 for which we have to go up. So x1 is 44, n1 is 80. 44 and 80. So we write here 44 for x1, n1 is 80. Okay. And then again we move up. Oops. So x2 is 41 and n2 is 90. 41 and 90. So we type in here x2 is 41, n2 is 90. Okay, so let's fill it up. X1 is 44, n1 is 80, x2 is 41, and n2 is 90. And then we scroll down to calculate. Okay, so let me create some space. But before I do that, I want to make sure I remember the alpha. I believe the alpha was 0.01. Okay, at alpha equal to 0.01. So, okay, so after this, we calculate. So we bring the cursor on calculate. We'll get a test statistic and a corresponding p-value. Okay. So the test statistic z, which is your test statistic, is equal to 1 point, you might say 23, and the p-value is 0.218. Okay, alpha value given. This is level of significance. This is given to us. Level of significance is 0.01. So P is greater than alpha. Decision: do not reject H0. Conclusion: at alpha equal to 0.01, there is not enough evidence. This is point. There is not enough evidence to support. Not enough evidence to support HA, which states P1 minus P2 is not equal to 0. Okay. So the second part of the problem. So if I move it on. Second part of the problem. Second part. Calculate the 99% confidence interval for the difference in two population proportion. Okay. So how do I do that? Again, I'll press the stat button, then highlight test on the top row. The stat button, test button, and then scroll down, not to 2prop z test. You are going to go to 2prop z int. So you are going to 2 proportion prop z interval and hit enter. So all the information I've filled in, we just might need to make one change. So let's take a look at it. X1 is 44, N1 is 80, X2 is 41, N2 is 90. Only the C level has to be changed because we are interested in 0.99, 99% confidence interval. And then we go down to calculate. And hit enter. Okay, so what do we get for the interval? Minus 0.10, comma 0.29. What does it mean? With 99% confidence, we can state that the actual difference in two population proportions will fall between minus 0.1 and 0.29. Now let's draw the number line. So 0 is somewhere over here. So this is the number line. Minus 0.1 is over here on the left of 0. So this is your lower boundary. And your upper boundary is 0.29, somewhere over here. Okay, so if I move this up, notice 0 is a point inside the 99% confidence interval for P1 minus P2. Thus, a possible value of P1 minus P2 could be 0. Remember, null hypothesis was P1 minus P2 equal to 0, and alternate is P1 minus P2 not equal to 0. Okay. Since 0 is inside the 99% confidence interval, for difference, confidence interval for P1 minus P2, decision, do not reject H0. This is same as above. So bottom line, whether you calculate the confidence interval or you do the two-prop z-test, you reach the same conclusion, that is at alpha equal to 0.01, there is not enough evidence to support the alternate, which is P1 minus P2 greater than 0. Because you do not reject the null hypothesis, therefore you do not support the alternate hypothesis. So I will stop here today. If you have any question or comment, you write me a note. I will get back to you as soon as possible. If you like this video, please give me a thumbs up. I really appreciate that. Please share this video with your friends if you like it. And you and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll come back next time with another interesting problem, interesting solution. Thanks for watching. Take care. Have a nice day. See you next time.